Hi, everyone. Welcome back to our Seasons of Reliability Fall Live Event Series. I'm Brittany Stover, and I'm excited to guide you through today's session, The Gift of Early Detection. As we head into the season of gratitude, today's all about celebrating the impact of early detection and the people who make it happen every single day. Whether you're a maintenance tech, reliability leader, or somewhere in between, this session is a chance to kind of reflect and appreciate the wins that come from catching issues before they catch us. Before we get started, and I've got Maureen and Jeremy here today for a really great conversation that we're going to have, wanted to make sure that we go over just a couple of housekeeping notes. Feel free to drop your questions or comments in the chat anytime. We'll be watching that throughout the session. The session is being recorded and you will receive a replay back afterwards. And we'll share key highlights once we wrap up. So there's no need to take notes, just kind of be along for the journey. We'll love to chat with everybody in the chat. So with that, we're going to settle in and let's get started. Hey, Maureen. Hi, Jeremy.
Hello. Thanks for the intro, Britt. Welcome everybody. We're excited for, as Britt said, kind of round 2 of our fall live event series. This is kind of a new way that we're trying to connect with our with all of you in a little more kind of fun and maybe informal way. So last month we kicked things off with kind of sitting around the proverbial campfire and telling what could have been scary stories, but because of ultrasound saving the day, they turned into positive wins for our customers. So that was kind of a fun way to kick this series off. And today we're going to kind of turn the tables to more of a reasons for being thankful for ultrasound and all the different ways that ultrasound can have a positive impact at your facilities. So again, thank you all for being here with us and spending your lunch hour. Jeremy, I'll let you say hi. We missed you on the last one. He was supposed to be sitting around that campfire with us, but flight delays got the better of him. So Jeremy, welcome to the fun here.
Hi, everyone. Good joining.
Awesome. So, all right. So we are going to get rolling here. So today, we know we've got a lot of you here from all different types of industries. We've got folks from food and beverage, pharmaceuticals, manufacturing, etc. But I think we can all agree that the problems that folks are facing are not industry specific. So we know there's all kinds of things in the reliability world that can be tough right now, whether it's rising costs, aging infrastructure, aging workforce, the skills gap. All those things are leading to a lot of challenges. But we're not here to harp on problems. We're here to talk about the solutions that we can help provide. So today we're going to talk kind of through the 6 top reasons to be thankful for ultrasound and show you all how this simple, powerful technology can turn your biggest challenges into real advantages. So as we go through this, you're going to hear kind of all the different ways we can use ultrasound and the different applications that it can cover, but more important, the different problems that it can help you solve, because at the end of the day, that's really what we're here to do, is to be a solution to what ails you. So before we dive in, we would love to just kind of get a pulse of who here is actually already using ultrasound at your facility. And so we'll let that kind of play out here as folks give their answers. It looks right now like it's a bit of a 50-50 split, which is interesting and kind of staying there. So, we got some more folks chiming in. Now we're seeing people more. Back to 50-50. All right. Well, appreciate you guys participating in that. And thanks, Britt, for throwing that up there. Okay, so let's dive in. So reason number 1 to be thankful for ultrasound. So again, as we just were mentioning, we know that a lot of folks are dealing with staffing shortages, skills gaps, fewer resources. And why we're thankful for ultrasound is that ultrasound ultrasound can help teams work smarter, not harder. Very easy to learn technology where you can have very clear routes, very clear procedures, and we can really equip your teams to do more with less. And there's a few different ways that we can do that that we will go through. But just to kind of put the facts out there so that we're not just saying it, it is true. So this study done by Deloitte is telling us that by 2028, there will be 4.6 million manufacturing jobs that are going to be added to the industry, and that only about 2.2 million of those are going to be filled. So this is a real problem that needs real solutions. So of course, when we talk about adding a technology, sometimes people think, well, that isn't that going to create more work for us? Now we have something new we have to learn how to use. We have something new that we have to actually implement. But what's great about ultrasound, and for those that are already using it, you've hopefully already realized this, is that it is very easy to use, it's cost effective, and it's very versatile because of all the different ways that we can use it. So this is hopefully going to be something that doesn't require as much training. So in that skills gap issue, we can actually make good use of this technology. And one of the coolest ways that we can do that is with the birth of this acoustic imaging and these acoustic imaging cameras. So here, what we're able to do is we're taking what ultrasound, what we traditionally would hear, and we're being able to visualize it. So we can now, right there on the screen, we can actually visually see things like compressed air leaks or gas leaks. We can see faulty bearings. We can see partial discharge issues right there without really much training whatsoever, to help equip our teams with a very easy to use tool that can get a lot of things done. For instance, at this paper manufacturing facility, in just a quick 20-minute scan, this inspector was able to find just 12 compressed air leaks that were worth over $4,000 a year. So very quick, very easy, even in a noisy, kind of harsh environment, able to find problems, hopefully they fixed those problems, and created a real solution for their team. And so what, again, with the acoustic imaging and with ultrasound, really has a good impact because we've got that AI decision support built into it. So we're able to give this kind of a tool to our less skilled technicians to go out and collect data, again, very easily, as you see. And then we can have our more experienced technicians actually then going and analyzing that data that's collected in the field. So because we have Wi-Fi transfer of data from those cameras, while that technician's out in the field, they can be transferring that data up to the cloud. And then the more skilled person who's back at their desk, they can be looking at the information that's coming in and making decisions on corrective actions that need to take place. So this is a really great way to take advantage of both your less skilled and your more skilled and experienced folks. And another way that we're helping do more with less in regards to acoustic imaging is with the speed of inspections. So if we can reduce inspection time by 50 to 90% compared to our traditional methods, we can see a cost savings of, or a time savings of, like, let's say a traditional 40-hour inspection can now take 20. And if we quantify that out, we can see a savings of, let's say, $4,000 in labor savings. So where can we spend that money differently? So again, able to do more with less with ultrasound. And the future of ultrasound is going to help us continue to do that even more with our connected automated solutions. So you see here on the screen, we've got our on-track wireless system, which is going to allow us to put wireless sensors, and those are going to be monitoring our bearings 24/7, sending that data and those insights up into the cloud, and then able to send signals down to our single point lubricators to lubricate our bearings at the exact right time with the exact right amount of lubrication and the right type. And all, obviously there is some human interaction involved to analyze that data and whatnot, but we're taking that traditional, route-based lubrication process and bearing health monitoring from someone having to go out point by point, and we're making it much more automated and much more like smarter. And so this is a solution in our next series, just giving a little shout out. Next month, we're going to be talking all about how ultrasound can help you achieve better lubrication practices, better bearing health. And the on-track wireless is going to be talked about in much greater detail there. So just a little hint to get registered for December where we can learn even more about that. But again, all the different ways that ultrasound can help us do more with less resources and less people. Okay, and so moving along to reason number 2 to be thankful for ultrasound. So we know that there are supply chain delays. We know that especially unplanned repairs and downtime can be much more expensive. And so we are thankful for ultrasound because we can have much earlier fault detection, which gives our maintenance teams time to plan, to schedule repairs, and to avoid those costly emergency downtimes. Ultrasound is going to help us keep our assets running longer and prevent surprise failures. So this is a great reason to be thankful for ultrasound. So in true presentation format here, we've got our P to F curve to just show you that ultrasound is going to be that earliest indicator of a potential failure. And again, giving us that longer amount of time to proactively plan and schedule safe, more cost-effective repairs. And Jeremy, you've actually got a couple examples here you're going to talk us through of exactly ultrasound doing just that.
Yeah. So on this one here, this was a large distribution facility, and to kind of give a little bit of a story behind it. When they started out, they had a lot of experienced folks who, before they did everything, all their maintenance was typically done by screwdriver. They go out there and just listen with their ears audibly, and generally they thought it kind of got them by. The problem was, though, is that was the most experienced technicians that were doing that over the years. As Maureen mentioned in that first challenge there, manpower and a lot of transition and turnover has been a big issue. And that in this case, that was a problem here. So you had some newer technicians that weren't as familiar with the equipment that were going out there and trying to diagnose. And in this area, you have a lot of rollers. You can see in the picture there. There's a lot of moving rollers, and you also have product that's moving across the rollers. So everything's generating a lot of noise. So if you're standing there and you're trying to listen with your ears, or you're poking around with a screwdriver and trying to listen, it's really challenging and hard to isolate where it was at. So what the team did is they had one technician there who really grasped technology and was pretty excited. He grabbed the Ultra 15,000 and went out there and did an airborne scan first. Just trying to narrow down where was the sound coming from. What they did is they were able to isolate on the discharge end of the sorter. Now, mind you, this is the main sorter, so if this goes down, they're not moving product. If they're not moving product, you've got trucks waiting, you've got customers waiting on shipments and whatnot. So it stacks up and gets a lot of stress going there. So with this, the main sorter, they wanted to make sure that they could avoid that downtime, that unexpected downtime. So once they were able to isolate it, it was on the discharge end of that sorter. Then they used the contact approach, and then they were able to touch out of these bearings. And 3 of the 4 bearings that they tested sounded great. And they were within their normal range of about 6 to 9 decibels is where they typically operated. On the 4th one, though, they tested, and it was about 60 decibels. And it was just screaming at them, making all kinds of noise in there. So that kind of stood out there. That was the source, because the sound is going to be loudest at the source. But what this meant for them is because they caught it early, it didn't take anything else out with it. It didn't take a big belt out and additional rollers and motors and things with it. They were able to just change the component that needed to be changed. And what that did is it saved them about 3 hours of downtime. In that stacked impact there, from that 3 hours of downtime that they saved, it saved them about $370,000. But really, my favorite part of that story, though, was the feedback. Beforehand, is there was a little bit of skepticism, and like Maureen mentioned, nobody likes to do things differently or change. But the feedback that we got from this afterwards wasn't skepticism; it was relief. It was relief that they caught it early, and even more thankful they got to fix it on their terms. And it was in a safe and controlled window. It wasn't scrambling around with operations, on their back. And that kind of ties into my my next case study here that we're going to present here. And honestly, it's a lot of the same kind of feedback that we get. Is folks like the fact that ultrasound tells them more about what their equipment is, or more about what's going on with their equipment. A lot of times we rely on assumptions in maintenance. We're going out there, we're looking at what we think would be the most obvious reason. Sometimes, though, that causes us to put blinders on, and that leads a lot of wasted time and frustration there too. And that's example in this one here for electrical. This was at a high volume print on demand facility. So they have a fixation pump, and it mixes solution with water. And if that pump goes down, the ink, it doesn't bind to the fabric anymore. So then it makes a big mess, and then they have wasted product, and then production has to stop. But the most important thing about that, though, is there's no backup on the system. There's no redundancy. It has to run. So the team was going out and they were doing their normal inspections. They do a visual inspection, and they heard a crackling noise at this pump. So the first thought, it's a pump. It's got to be cavitation. So they went out with the ultra probe, though. First, they messed with their pressures and whatnot, trying to get that cavitation out of there. Didn't work. Took the ultra probe out. We're able to take some readings. We're actually able to analyze the harmonics. And viewing those harmonics, they could see some of the voltage in there that was showing the stray 60 hertz electrical anomalies. And then there's also some peaks. It's kind of hard to see in the picture there. You probably can't view it there. But around 144 hertz, there were some peaks there as well. So that kind of suggested there might be some early bearing wear. But the real issue wasn't the mechanical issue. It was that 60 hertz harmonics that was appearing there. So they isolated the pump. They checked the grounding. They corrected the stray voltage that was occurring there. And the crackling actually disappeared right there on the spot. They were standing there with the ultra probe and were able to listen to it go away. The pump went right back to its stable flow pattern. So, and again, the impact was huge for them. It doesn't necessarily look like a catastrophic impact there, but for them, it was big because of production. It avoided a full process stoppage, and it prevented any defects from, any of the product that did go out down the line too. But it also reduced like any kind of electrical and fire risk, and protected throughput in the area with a zero redundancy. If that pump doesn't run, no production's happening. So really the takeaway from that was simple. They're thankful they caught it early and didn't spend the day chasing the wrong problems there. And I think Maureen's going to walk us through the next one about leaks.
Yep. So thank you, Jeremy. The great examples there. So now reason 3 to be thankful for ultrasound. So we know that every leak, every steam loss, every inefficiency is a waste of your money, waste of resources, waste of energy. So why we're thankful for ultrasound is that we can do things like leak detection. We can listen for improperly functioning steam traps, and we can solve those problems again before they're wasting too much of our energy, too much inefficiencies, etc. So here's just some numbers for you. So 3.2 billion is the annual waste from poorly manufactured, poorly maintained compressed air systems. We know that 20 to 30% of compressed air systems is wasted from leaks alone. And we know that the average cost of a compressed air leak is $17,000 annually. But we also know that we can reduce those issues by finding those leaks with ultrasound. And we jump back into because it really is our best and most efficient way to do leak detection is with acoustic imaging. And of course, here you can see a couple actual reports that were developed, that were created after a leak study was done with the camera. And so just very easily being able to visually see the actual cost savings that we can realize from doing compressed air leak surveys with our acoustic imaging cameras. So of course the big thing here again is not just finding, not just quantifying, but of course fixing the problems so that we can save that wasted energy. Just another example here, this was at a brewery. And this technician went out and found a CO2 leak that was costing about a little over $13,000 a year. So again, these are real losses that are likely happening at your facilities that you're just not hearing. But again, with ultrasound, we can actually go pinpoint those issues, quantify them, fix them, and hopefully, celebrate those wins so that your teams can be thankful for you for bringing these problems to light. Okay, and so reason number 4, probably, well, there's another one that we're probably most thankful for, but this is probably second on the list. Safety. Safety, we know, does not take a holiday. And so we understand that, especially electrical faults, things like arc flash, they can be very dangerous, cause very dangerous situations. We also know that emergency repairs can also lead to very unsafe conditions. So why we're thankful for ultrasound in this respect is we can detect things like partial discharge and find any of those potential arcing hazards before they become a real problem. And because we of course want to keep our technicians safe and heading home to your families every night. And also, again, because of all the things we've been talking about, early detection, we understand that planned and scheduled repairs are also 40% safer to conduct. And so ultrasound from a safety perspective is something for sure to be thankful for. And Jeremy, I'll let you jump in and give some more specifics here.
Sure. So, reason number 4 for electrical safety, it's pretty simple, really, is we all want to come home at the end of the day, right? And hopefully in the same piece that we left in. So electrical safety, it's a big reason teams lean on ultrasound. Like Maureen mentioned, it's a safety side of things. Like, I'm not an electrician. So when I go out and do inspections, I don't have any business opening up any panels or sticking my head or hands in anywhere like that. But I do want to know that if I'm going to possibly be exposed to a risk, or if there's any risk in the environment there that could potentially affect me or any others that are out there with me, or also the equipment. And a lot of times with corona tracking and arcing, some of these things that we can detect with ultrasound here, they happen without necessarily a visible sign or something that we can see, that's in an enclosed panel or in a area that we shouldn't, like, again, stick our head into. So what it does is it helps give us a safe, controlled way to detect those problems without exposing ourselves to the risk. And that alone right there is just something to be thankful for, I think, is we can be safe with it. We can do our jobs without having to necessarily worry about that. And like I said, with corona tracking and arcing, they all create distinct high frequency emissions. So when you hear something, it gets our attention. We should take a closer look. So when you scan with the ultra probe or use the acoustic imaging camera, these signals translate then as something we can hear, and then we can analyze them, and we can take the guesswork out of it. And so instead of saying, well, I think something's in there, let's open it up and hope for the best, or let's get all suited up in the arc flash suit and open it up, we can have a good idea beforehand. And then in my case, I'm not an electrician, so I can call the correct people, call the people that do know what they're doing to come in there and open it up or do whatever precautions they needed to do. So the case study I'm going to share here. So this was a team that was going out and they do their normal inspections and they do their cabinet scans. So they do an external scan with an airborne using UltraPro 10,000. And they're scanning and listening for any kind of electrical discharge or any kind of sounds that sound abnormal to them. Typically, you'll go out and you'll scan the whole area. The kind of rule of thumb is no noise is good news. In this case, they scanned and all of a sudden they came up to something that sounded really violent, basically is kind of the best way to describe it. They knew though, like, hey, we don't want to open that up. Something is not right. So they recorded the sound. They thought they had a good idea of what it was, recorded the sound, and Maureen, you want to play that for us?
Yeah, give me 1 second. I have to reshare my screen to do the audio. If I have it like that the whole time, I'm told there was an echo. So just bear with us. We're trying to.
So when they heard the sound, but when they analyzed it, that was the most important thing, is because not only because they could make a good assumption, they could also prove it. And as most of us have to nowadays, we have to document and prove everything, right? So what they did is they were able to play it, and the pattern was pretty clear. So I'll let you hear it first. Okay. So we hear it, and at first glance, it almost just sounds like somebody's just kind of scooting along and maybe rubbing something there. But it was actually, again, at that discharge, the signature there displayed it. It was classic arcing. And if we have arcing there, we don't consider arcing as something we measure and we say, well, let's see how bad it is in a month or in a couple of weeks. We want to take immediate action on that. So what they did is they brought the right folks in with the electrical team. They were able to open the cabinet safely with the right PPE on. What they found, it lined up exactly with what the ultrasound had already pointed them to. First off, visually, you could look at it, and it's kind of hard on the picture there, but there was some blackening around the connections there. But also IR was able to confirm there was hot spots in there where that had occurred. So, this is something that typically wouldn't have been caught until it was catastrophic or potentially a safety hazard for somebody. So it could have been missed and possibly ignored. But ultrasound helped them catch it early and then deal with it right away, the correct way, with the right folks and safely. So, and that kind of goes into the next one here is our planned maintenance. Maureen mentioned this earlier of anytime we can do something planned and a safer situation, it's always going to be a lot better for us. And just like with anything, whether it's our health or anything else, the sooner that we find it and address it, we can control it and take better measures there. So for this one, we can see the accident rates. They're 40% lower when maintenance happens. That's a big one. When work happens in a planned environment instead of emergency, everything becomes safer. The accident rates drop. The crews aren't rushing around. You don't have people screaming at you over the radio. You're not opening up panels just trying to get it done. You're not climbing over equipment and trying to scramble around, getting yourself caught in things. We saw it in the bearing example. You see it in the electrical examples too. Early detection, it's given us the time and the safety that we need. And speaking of safety, the next one here, every facility that I go to, we always find unsafe or difficult areas to access. And you can see from some of the examples there, most of the time, the equipment that we really want to monitor or really need to monitor is barricaded, hard to reach, unsafe, or just really, really difficult to get to. And that's where, the RAS sensors come in. So whether you need, just basically an extension of your ultra probe for your routes, you would use a RAS sensor. You could plug it into there and you could route your cable safely and plug in. Or, if you're in a area where you have a lot of those areas, you can combine those all, condense those all into a switch box. So now you've got 8 test locations from one area. So now we're addressing multiple concerns here, because now we're addressing our manpower issues. Instead of taking 45 minutes to an hour to take a route, we're condensing that down to maybe 20 minutes. But also the safety factor of that, of going to it. But also if you have, sometimes we have those situations of that critical equipment that needs 24/7 monitoring. We need to know what's going on with it at all times, and possibly even remote lubrication to make sure that it's getting the right amount of grease at the right times and operating in those prime conditions. So whether either one of those options, you have a way to still reach those unsafe areas, on track or the RAS, depending on what your needs are for the data. And that ties in the next case study here. So sometimes, accessibility isn't just because it's hard to get to or because it's maybe unsafe. maybe we just don't want to get to it. And some of us, we're kind of coming up on that time of year where doing maintenance outside for those areas, I don't envy you. I'll just leave it at that. I've been into some of those areas and I don't envy you. I don't blame you for not wanting to get to those areas up there. And that's where example of the RAS sensors or the on track comes into play. And this here is a good example of one. In this case, extreme winter conditions, it was almost impossible to access these conveyor bearings. Typically what it would require is a technician to climb up a ladder. And this ladder wasn't just a 6-foot ladder. It was really tall ladder up that you had to climb up, and it was very narrow. So when you're in extreme winter conditions, it's cold, icy, a lot of unsafe things that could happen there. So a lot of times what would happen is these conveyors weren't even getting monitored. It would just get tested during the summertime only. On-track wireless was able to solve that problem. It really solved multiple problems. We could monitor it. We knew exactly what was going on, but also based on what the data was telling us, we were able to look at it and we could lubricate the bearings on demand. The right amount of grease, not a guesswork of a couple shots here and there, is the exact amount that they needed in those conditions. And we did it remotely. They were able to sit there in their office and hit the button and make sure it happened. So even though it was terrible conditions outside, still able to get the data and still able to maintain it and make it operate in prime conditions. So they kept it healthy, but it also kept people safe, right? And that's the big part of it. So really, every industry, everyone has difficult and unsafe areas to get to. Sometimes seasonally makes it even harder. So those are kind of ways that tied in there. And these folks were certainly thankful then, in that case, for Ultrasound being there to make their day a little bit easier. That's for sure.
Yeah, and I can imagine the opposite is true for folks where in the summer is not the time you want to be going to places like this. So, but yeah, so just, again, safety being clearly very important to everybody that is listening in here today. So thankful for all the safety aspects that ultrasound can bring to our customers and to all of you. So moving on, reason number 5. So maintenance programs often relying on reactive fixes or inconsistent or at times overwhelming amounts of data. Nowadays, I think a benefit of all the different ways that we can collect data is great. However, sometimes there's just so much of it that we need to sometimes cut out that noise. And so ultrasound we're thankful for because it can provide measurable, repeatable data that turns condition monitoring into confident action, helping teams prove ROI and act on meaningful data. And I'm going to re-share my screen again because I do have a couple sound files that we're going to play in this next one, and I need to share the audio. But again, we'll have to figure out for future ones why the echo is happening. So bear with us. I'll unshare it again after we get through this. Okay, so here's just an example of being able to take action based on findings in the field. And so here's an example from a tire manufacturing plant. We had 2 side-by-side motors, and they were producing the same decibel value, 35 dB. So if you didn't listen, if you didn't look at the sound signatures, you might think, well, these motors are both within the, maybe whatever their baseline readings are, they're within that range, they're both at the same decibel. If we actually listen, we know that there is something not quite right. So let's listen to motor 1. So pretty clean sound there. Now we're going to listen to motor 2. Whoops. Okay, didn't quite sound the same, did it? And I'm going to just real quick, because if that echo's happening, reshare here. So definitely, same decibel reading, however, clearly very different things happening with those motors. And so because they were using the UltraProbe 15,000, and you can even see here on the picture, they can actually pull up the FFT to look at the sound signature right there in the field. And so when they did that, they see that motor one that we just listened to, and definitely sounded good, it visually is looking exactly as what we want to see from a VFD. And if we then look at what motor two was showing us is, we obviously have a lot going on here. And what they determined right there was that there's likely some sort of fluting or potentially a mechanical looseness situation happening. And so right then they were able to go and grab vibration to come in and do some further analysis. So ultrasound giving that quick indicator if something is not right, analyzing it right there in the field, and then making an actual decision on what to do next. Another example of that, again, with the acoustic imaging cameras, being able to use AI directly on the cameras to know what it is that we are now seeing when it comes to the camera. And so here was a technician out doing some electrical scans. They took this picture with the camera. There's an anomaly here on the screen. And literally right there on the camera, it tells you what it is that you're seeing. In this case, it was surface or internal discharge. And it indicates here that this actually could be strong and rapidly escalating. And it gives you an immediate recommendation right there on the screen. And in this case, it's telling that person to take immediate action. So again, being able right in the field to have important information, important data that we can take corrective action and know exactly what that action should be right there. So pretty cool way to be able to improve reliability at your facility with ultrasound in that regard. And so now we're coming up to what I think is the number one reason to be thankful for ultrasound. And it's that great tools and technology, of course, mean nothing without great people. And so we are thankful for all of you that are here today, that are out there putting technology into use to get actual results. And we've got some images here from some of our great customers around the globe. We've actually trained so far this year globally over 2,000 technicians. So 2,000 people who have taken the time, taken their training dollars, their resources to learn how to use this technology, how to put it into practice at their facilities to help maintain a safe and reliable facility. And we're just really grateful for all these folks who sit in on our level 1 classes. You can see here we've got folks taking our online class, folks here taking our in-person, and then out in the field improving their skills. And we're just really grateful for all of that. Jeremy, you're out and about with our customers much more than I am. So maybe you've got a few things you want to add to that before we wrap things up.
Yeah, I would say I think folks would sorry.
I just put you on.
Yeah.
Well, think about your teams that you've been, training, and the aha moments that they're out there having. I mean, even the case studies you were sharing, those are your customers that you've worked with.
Mm-hmm.
It's pretty cool to see.
Yeah, it's really cool to see them, and I think that's the thing is, it's rewarding to see folks work through the challenges when it's tough to make the changes, and especially dealing with the manpower issues and the time and whatnot. Seeing them work through it and then getting that aha moment, to where it does, like, it clicks and it works, but also not only does it work, but it works for them. It's something they can use to make their job easier and safer and get things done.
Yeah, awesome. All right, well, that's what we have for you guys today. Britt, looks like we've had some interaction and answering some questions, but are there any questions that we should dive into before we let everybody head on their way?
Yeah, definitely. And Maureen, Jeremy, thank you so much. I think these are fantastic stories and reasons for us to be thankful. So we do have a couple that have come in. The first one is, what do we typically find is the main reason people don't implement a technology like ultrasound?
Jeremy?
I think the main reason is again change. Just the fact of, hey, we've done it this way before. Why do something different? The resistance to change of maybe even purchasing something different. If your technicians seem resistant, don't want to try it, or don't understand the meaning behind it or the reasons behind it, I think that's usually the biggest hurdle that they face.
Awesome. And then someone asked, how does acoustic imaging like actually work?
Well, so essentially the cameras have these MEM sensors, and that's what's translating the ultrasound, the sound into the visual image on the camera. That's a very high level explanation of it, but essentially it's taking the sound and turning it into something visual on the screen. And so we can then, see where the problems are, and with all the AI that's built in, uh, to actually then know what the issues are that the camera is seeing.
Yeah, and I think that's a great one that we can probably dive in forward more now that we've got information and things like that. The ultrasound, the 2000 is a great tool for steam trap checking. As what
Oh yeah, the old 2000. Yep. Oldie but a goodie. Still, yeah.
Yeah. And so mentioning ultrasound 2000, Ultra Pro 2000, we've got the cameras, we have RASs, we have all kinds of things. But what is a good way in your recommendation for somebody to want to get started into making and shaping their program?
I'd recommend obviously purchasing the right tools for the job, making sure that you talk to one of our folks to make sure that we get you the right tool for the job, but also then the right training for the right people. I think training is the foundation of it all. The right tools, the right foundation, combined with the right people. I think you can have success that way.
Awesome. Another question is, what area of your plant gives you the most troubling detecting issues early?
Is that a question for us or?
Yeah, that's for you, Jeremy.
It's for one of you.
That'd be a good one. I'd like to ask the audience that as well.
Audience, yeah, that's right. Feel free to chime in the chat, folks. On that one.
Yeah. But I would say from what I've seen, I think the hard to reach areas, there's a lot of safety things that come into play nowadays. The guarding, the barricading, and also things like on upper levels and whatnot, making it harder and harder for folks to work on things. And I think that creates a challenge then because things get neglected. So I think that those areas are probably the most commonly needed and most often neglected, though.
Definitely. Well, I think that's all the time that we have for today. Some of the questions that were asked, we'll be able to kind of get in touch with you in areas that are specific to your needs so that we can make sure that you get that right, solution. And so thank you so much, Jeremy, Maureen, for joining us, the insights. Early detection, it is that gift. And we are very thankful to all the people that work alongside us, our customers, everybody that's continuing to get trained to make the world more safe, more reliable, and the people that do it. We have one final session in the Seasons of Reliability series. It's coming up on December 17th. So if you haven't had a chance to kind of go over and register for that, we'd love to have you wrap this year's journey together. Lots of great things to come. So if you have a great happy Thanksgiving and rest of the day. Hope you have a wonderful day ahead, and we'll chat with you on the next time.
Thanks, everybody. Happy
Thanks, everyone.
Thanksgiving.